Let's look at another graph of a polynomial and see what we can figure out about the polynomial. Again, notice that this graph has been cut. We know it's a polynomial graph, but it is discontinuous right now, which means not continuous. Remember, continuous means that it can be drawn without lifting your pencil. There are no breaks. So we need to connect our two pieces together. And you don't have to go further up because this is just an estimate for us. And I'm going to put arrows at the end so I know what's happening. Notice on the left side, we rise, which means that we go up. And on the right side, we also rise. It's pointing up, which means that our arms are the same. And if our arms are the same, that means that our function is even. When our arms are opposite, that means they are odd. We care about how we end on the right-hand side. How do you finish your graph when we're drawing from left to right? Because the right side rises, we're ending on a positive note, which means that our leading coefficient is going to be positive. With our zeros of the function, remember we need to go along the x-axis and see where we touch and turn or cross the x-axis. So notice we have one here at -3, another one at 0, and one at 1. Those are the only places we touch or cross the x-axis, which means our zeros are x equal to -3, x equal to 0, and x equal to 1. We're going to do part D and E together. At which zeros does the function cross the x-axis, which means going from above to below the x-axis or from below to above, either way. And at which zeros does the function touch and turn? And remember, touch and turn is the same thing as bounce. Whichever you're more comfortable with, just know that they mean the same thing. If we look at our first function, our graph comes down, not first function. If we look at our first zero, our graph comes down, hits -3, and turns right back around, which means that we are bouncing or touching and turning at x equal to 3. Coming close to x equal to 0, starting on the left-hand side, we come down, we touch x equal to 0, and then we turn back around. Touch and turn or bounce at x equal to 0. And for x equal to 1, the left-hand side, we come down, we touch it, and then pop right back up, which means that we also touch and turn it or bounce at x equal to 1. We have used all of our zeros, which means that the zeros where the function crosses the x-axis do not exist, D and E. Now that we have the behavior, let's see what we can figure out about their multiplicities. Even multiplicity, remember, means that you touch and turn at the graph, at the 0. Remember, touch and turn is same as bounce. And if you're odd, the graph crosses at the x-intercept 0 root solution. So since all of ours touch and turn, all of them are going to have even multiplicity. So x equal to -3, x equal to 0, and x equal to 1 all have even multiplicity. And because we did not have any x-intercepts that had an odd multiplicity, we're going to say D and E does not exist. Everybody's favorite, Turning points to find the minimum degree. Get back in your cars. Let's go for a drive on the graph of the polynomial. Starting from left to right, we're driving. We're headed south. And we hit a turn. We got to move the wheel. Turn to the left quick. That's our first turn. All right, we navigated that sharp hairpin turn. We're coming around. We're coming around. Oh, there's a nice leisurely turn. That's our second turn. We've turned our wheel only to the right to come around that ledge. So we come across, coming down. Oh, we have another turn at x equals 0. That's going to be our third turn. But coming up, oh no, there's another quick turn, which is a 4. Then we come back down to x equal to 1. Ah, crap, there's another turn. There's a fifth turn. It was really quick. Turn, turn, turn. Turn the wheel. And then we drive off into the positive infinities, which means that we have 5 different turning points. Okay. And if we have 5 turning points, remember that our degree, our minimum degree, is going to be our number of turning points, which we said was 5 plus 1, which means that the minimum degree, and remember we use n for degree, is 6. To get from degree to max number of turning points, subtract 1, working backwards. But to get from turning points to degree, we have to add 1. Part I, we need to find the least possible degree function, and we just said n was 6. So all of our multiplicities or our exponents need to add up to 6. Because we're in factored form, not standard. We're going to have parentheses. And we need to have all of this information in this function. So let's name our function. I already had p of x and f of x, so this time I'm going to use h of x. We said that we needed a positive leading coefficient in part B because the right side rises. So I'm going to have a 1 for now. With our x-intercepts, we had an x equal to -3, which gives us the factor x plus 3. We have x equal to 0, which gives us x minus 0 if you want. I'm going to make that a little bit nicer here in a second. And x equal to 1 gets us x minus 1. So we have our factors. We need to put in our multiplicities. And we said that all 3 of these have an even multiplicity, and that's because the graph touched and turned at each of these x-intercepts, zeros, root solutions, all the same thing. The smallest even number we know is 2. And we said all of them have even, so all of them have a 2. If we check the minimum degree, we would have 2 plus 2 plus 2, which is 6. So that's okay. Let's go ahead and make this look a little bit nicer because we have all the information we need. So we're going to have h of x is equal to, I don't have to put the 1 since we're multiplying by a positive 1, but you can if you want. X plus 3, quantity squared. X minus 0 is just x squared. And then we have x minus 1 squared. Now, technically, this is not wrong as it is written, but it looks really, really weird to have that x squared in the middle. If he had his own parentheses still, he would be fine. But since he is by himself, let's move him out front. So we're going to have h of x is equal to x squared times x plus 3 squared times x minus 1 squared. Again, if you want to write your leading coefficient of 1, you can. It's not required. And if you had the x minus 0, that is fine as well. It's just not as simplified as it could be.